Hello, this is a video for SOEN6441. This is Advanced Programming Practices. This is week 3. It's going to be 2 videos for this week. This one is going to be repositories, and then the second one is going to be coding conventions. So this is essentially showing how to use a software repository, well, or more, what's the advantage of using a software repository? Because it's one thing to learn, to use a tool. It's, I believe, as important to understand why you should be using a tool. Forgot to share. This one, okay. This is about repositories, or more practically known as a revision control system. So as I mentioned earlier, this course is, large part of this course is to show the students what are the tools that are being used in practice to manage the act of programming. The provision control system is one of those basic tools that has been there for a long time, but has not been practically used widespread so much since before the last 10 years, I might say. So it's been there for much longer than that, but more and more you see it, you saw it being used in the industry. And these years, it's, if you want to work in the software development industry, you must know what is revision control. Practically all companies are using revision control nowadays. So if you don't know it, it's not good for you if you want to find a job. So what is it? So the thing is that when you're developing software, two things. You're developing most often software in teams, and most often what's happening with software is that it evolves. The code that you write will evolve in time, not necessarily in time after you have developed the code, but as you develop the code is actually, the code is changing. So as things are changing, you need to manage the change. Okay. What's make it worse is that normally you work in a team. So there are many people enacting changes on the same piece of code or the same code base. Okay. So you need absolutely to have something to manage these changes. That is what is revision controlled for. So you might say revision control is, in general, it's any kind of structured practice. The key word here is structured. If you're trying to do revision control and you don't have a structured way of doing it, if you're sharing files with USB sticks and so on, some people do that. It's you might see that you might have some experiences telling you that it's not working. It is not working. You need to have some kind of structured way to manage the different versions. So as I just introduced before, normally this is when you develop software, you're working in teams. So there are many people working on the same code base. And all of these people are actually creating multiple versions of this code all the time as they are changing the code. You might have done what you think is the final version. Somebody else is working on a new feature, needs to use the code that you built, and then realizes that as they're adding a new feature, needs to change your own code. So then your code will change, and then you will have to be made aware that this person has changed your code so that you can continue working on this code. So this is all a kind of a communication also issue, that as other people, as all the individuals are working, they are all made aware as quickly as possible of what are the changes that were applied by the other people. Okay. So yes, it's about maintaining the latest version, but if it's a very fast-paced development phase that you are in right now, and a lot of people people are making a lot of changes to the code very frequently during, for example, a week. And you absolutely need, if you want things to go smoothly, you absolutely need for everybody to actually update the the current version of the software with what they add almost in real time. Okay, or else everybody's going to start working on a version that is not up to date according to every one another's evolution in time of the code that they are working on. Okay. So that has to do with actually working simultaneously on updates and being aware of what are the updates that other people have made almost in real time as the changes are happening more and more quickly as you, for example, advance to the deadline, near the deadline for the build, for example. So very often that would require a software solution to actually enable this mechanism. Okay. That's what I'm going to explain in this course, and that's what I'm going to enforce that you actually use in the project. Of course, there's many people in this class that are probably listening to this video now and saying, well, I already know that. The fact of the matter is that I know that there is a large proportion of the class that never used that, or that made a very minimal use of it, or that did not use it in a team. So it's the idea is to make sure that you have a teamwork experience in using this tool. It's possible some of you already have a teamwork experience using revision control. Here, we're here to make sure that everybody is going to be at the same level at the end, right? Appropriate level at the end. So there are also many different variants of revision control that have been done. This idea has been there for a long time. That's one of those things that people may think it's new. It's not new. It's been there for a long time. So why would you use revision control? So here I'm listing basically the different reasons why you may need to actually use that. Don't think that there's reasons why you may not want to use it. Okay, if you're developing software, even I am developing software by myself, I actually use that to make sure that I keep track of the history of what I did. Okay, so that's a habit that you should take, that even if you're not working in the team, it's a good habit to have. And once you will have the habit to have it, to use it, it becomes like second nature. Okay, that's what you want to achieve. That has become a habit for you. So why would you want or need to actually use it? First reason, not that it's the most important, or not in order of importance or anything. First reason I list here, to have a common repository for all the project files, so that if you have different people working on a code base, that everybody is working on the same common version. Okay, so that it's not that everybody is working on their own code base and then from time to time they just happen to put it all together. Okay, so that constantly everybody, as much as possible, is working on the same common code base. Another thing that it enables, most of the solutions for revision control enable for remote connection. So even if you have a team that are not working in the same working environment, that they can actually be working on the same repository. Okay. These solutions are always network enabled. even if you'd be working in the same physical environment, and you might say, well, we have a file server, so we're going to use the same, let's say, directory on the file server to host our files. This is not going to solve the problem of concurrent changes and managing of the evolution of the different changes that you have applied on the files. Okay, so it's not about having only one place only, it's about managing the changes automatically. To make sure that the concurrent changes of the same file are properly handled. So it's possible that at a certain point in time, two different persons are actually making changes to the same file. So then they are working on their own version of the file. And then when you want to actually put these changes together, then there has to be some kind of verification as to how can you actually merge these two versions of the file together. If you would do that manually, it would be kind of tedious and error prone. So a revision control system will enable you to actually automatically make the merge, and if there's no conflicts, then it becomes very easy. Okay. If there are conflicts, as we shall see later, it's a little bit more complex, but at least it can be automated. Okay, the system can tell you if there are some conflicts. Might also allow branching and merging of different versions. So you can, in fact, have different branches of the evolution of your software. So you can have the main trunk, as we will see later. You can have the main trunk, that is the main version of your software. By a certain point in time, you can have, for example, a sub-team or a person that decides to go in a certain tangent. And this person or this sub-team wants to develop a certain thing that they want to try without actually influencing the main version of the software. So then they would decide to go on a branch, what's called a branch. And then once maybe they are satisfied that what they did as a try is actually working correctly, then they can actually branch back and do a merge with the main trunk of the evolution of the software. So branching and merging is a very important aspect, a useful aspect of revision control. And talking about merging, merging is an operation, as I mentioned before, that can be very tedious and frustrating if you do it by hand. In fact, even if you do it automatically using a revision control software, it can be frustrating, especially if there are some merge conflicts. Merge conflicts happens when you try to merge two files together. Two persons have changed the same file, you try to merge it together. If the two persons happen to have changed the same lines of code, of course, this cannot be automatically merged, and some human decisions have to be made as to how this will be merged together. But at least the revision control system will tell you where there's actually some merge conflicts. So it's not a fully automated system. If there's merge conflicts, you will have to have some kind of analysis and decisions to be made. Another thing is to avoid proliferation of different disjoint copies of files and projects. So if you don't have a revision system, then you end up having lots of different folders with different versions of the same code base. People have their own versions and so on. You don't want that. This is creating a lot of confusion, potentially taking a lot of time to resolve the confusion. Okay, so that's one of the main reasons why you want to use a revision control system. Essentially, to make sure that everybody in the team is always working with the correct version. So the question becomes, if there are several versions around, which one is the correct version? Everybody might say, well, mine is the correct version. The person will say the same. And the answer, a real answer, is that they have to merge everything together and make sure that all their good new things that they have done now are merged together. Okay, so that everybody hereafter, after it's been merged, everybody's working on this merged correct version. And if, for example, at certain point in time after you've tracked all the changes that were applied to the code base, if at certain point in time you realize something wrong was done, then you can actually roll back some of the changes. Every individual change that you have applied, you can actually undo the change. Yes, it is a very nice feature to have, but you know that undoing changes, looks easy to do, but it's not necessarily easy to apply, especially when there's a sequence and you want to undo a step that was done here. Possible, but not so easy. But at least then you have some kind of integrated solution that enables you to track the changes and undo some of them and see what's the effect of it and reapply the further steps in the sequence. Then also you can also compare. Let's say you want to see, well, I have a version here and I have a version here. And I want to compare what is the difference between the code in this version and the code in this version. Very easy to do. Okay. Very often you want to do that. For example, if you see that you are here and then you broke something, maybe you want to see what was before, so that as to see what was actually broken and how it was broken. And of course, if you have in time, for example, over the evolution, so you might have certain builds that you have delivered to the client or to your boss. So this way you can actually keep track of all the evolution and then tag some of the builds in time, okay? Because you keep track of all the changes. And then at some point in time, there comes a point where you have a stable version that you deliver. So you want to tag this one so that later on, if you want to fetch this stable version, you just basically tell the system, give me this version, compile it, and then run it. So it enables you to somehow go back in time and get something that was working at a certain point in time, according, for example, to a set of requirements. And what are the goals? Of course, it intersects somehow with reasons why you want to use it. But here I'm making it more abstract and high level. Okay. So what would be the goals of using such a tool from the perspective, for example, of what are the goals of a company? So why would a company want to use such a tool? So there's always a cost in adopting and using a tool. And then there's an advantage of using a tool. Very often a company would make a decision as to well, make a cost benefit analysis. Okay, so essentially what's happening here when you use this tool, you maximize the productivity of the programmers or the programming exercise by automating the code integration tasks. Every time you apply a new change, you have to integrate this change in the code base, in the whole code base. But sometimes integration of a new change takes time. Okay, and the more the change is sizable, the more it actually may have more difficulty to make the integration. So a solution like this would actually provide you with a tool to somehow automate this integration. Again, from the perspective of the cost, you would reduce the cost related to confusion and mistakes due to having different versions or having to do an integration exercise. So it's again about reducing cost. So it maximizes the productivity by automating the process of change, and also it reduces the cost by because it reduces confusion. And when you're confused, you spend more time doing your task, thus you are expending more money. Okay. It will maximize the software integrity, traceability, and the programmer accountability. So as, for example, as you are making changes, sometimes, or let's say you want to undo some changes that you made before. Very often when you want to undo something in a piece of software, the thing you are undoing might actually be used by other parts. So you have to somehow track the effect of actually undoing something on things that are using this thing. Okay. So a system like this might actually enable you to better track what are these dependencies and what is the enable you to better maintain the integrity of the software as you are making changes or undoing things that you did before. Traceability across the different of the evolution of the software allows you to trace exactly what is the sequence of changes that were applied through the evolution of the software, of the development of the software. And anytime there is a change to be applied, it's the change is actually associated with a user or a programmer. So it allows you to see who did what. If somebody made a mistake, then you may, or somebody did something important, you may come to them and then ask them, discuss with them about it. Whereas if there be no system like this, then all you know is that there is a piece of code there and you don't know who actually made it or changed it. So it gives you also accountability. So it also assists the developer in providing cost-efficient and coordinated changes to the software and its components. So it's good for coordinating efforts across a team, so that people are not only doing their own part every step of the way. As they're doing their part, their work is actually synchronized with the work of others. Okay. It's also recording the composition of the different versions of the software as everything is happening. It enables you also to reconstruct, as I mentioned before. If you want to, you're at a certain point and then you want to know what's the version that you had like 2 years ago, very easily you can get this, which is not the case if you don't have such a solution. So how does it work? So essentially what you have is somehow a place where you actually store the files that are not necessarily on your computer. So there are different models, but generally you actually store the repository on a server somewhere, so on another computer. So you are a worker, you are a programmer. So how it starts, so the first programmer that submits the first version creates the first version of the project, and then actually creates a repository and then commits this new first version on the repository. Then other people can actually connect to this repository, get this first version, and then different people can start working on this, the code base that is stored on the server. Okay. That's how it starts. Somebody creates new version of the project, creates a repository instance, and then somehow uploads their code onto the repository. Then other people can use it. So that's how it starts. You know, there are different ways, different technologies that can be used, the different software that enables you to do that. There's different models. They have each of their different terminology and so on. So I'm trying to be general here. So of course, I'm going to advocate that you use one of them. For this semester, we're going to advocate that you use GitHub. there are some other solutions, provided that you can demonstrate that you have the features that are that are necessary to have for us to do what we tell you that you must do, as I will say in the last part of this video. You can use whatever solution you want. Okay, so for example, there's I don't know, Bitbucket. It's almost exactly the same features as GitHub. So if you know Bitbucket better, then go ahead. Okay, but if you want to use something else, make sure that whatever we're asking you to be able to do, that you can do it with this something else. Also, if you use something else, it's possible that the lab instructors don't know what you are using. So make sure that if you want to make a decision as to use something specific that we don't cover in the lab, and you maybe want to have some help from the lab instructor, make sure that they know that so that they can help you. Okay. So yes, you can make your own choice as to which ones of the tools, these tools you would be using, but be careful. So then after, let's draw some kind of graph here. So you have the repository. So somebody, for example, on their PC, their computer, they created their project on their PC. Let's say, for example, using Eclipse. They created their project on their PC using Eclipse. And then they connect to this repository here, for example, GitHub. They connect on GitHub. And they say, create a new repository for me. And then it creates the repository. And then they basically connects this repository with this set of files here. And then uploads, somehow commits this project here inside of the repository on GitHub. Okay. Then that makes it so that somebody else with another PC or Mac then can actually connect to this repository on GitHub, get this here, and then open their Eclipse and then download this version that was uploaded here, and then they can start actually working on the same project. Then at this point in time, you would have two different people that are actually working on the same code. But as this person starts changing the code here, this does not change the code here right now. And this person here starts changing code here. So right away, what you see that starts happening is that they start diverging from one another as they make changes to the code. Now, the very important thing to realize is that you want to minimize this divergence as much as possible. Because the more these two persons start developing the code in their own way for longer and longer and longer, the more it actually diverges from one another, and the more it makes it probable that they will actually both want to change the same piece of code. And when two different people change the same, for example, class, you run the chance that you'll have a merge conflict after when you actually want to merge the code. That's why what you want to do is to, as frequently as possible, you update the version. You, for example, this person does a little bit of work and then makes an update. This person does a little bit of work, makes an update, or a commit, or a push, as it's called. So you want to do this as frequently as possible so as to reduce the two effects here. So as to reduce the probability that you will have a merge conflict, and also to make sure that, because as this person here is developing new code that is not in the current version, maybe this person wants to have or needs to have this code that is developed here. So as this person is making this code available here, then this person can continue their development using the code that was just uploaded here a few minutes before. Okay, so the more you commit your code or push your code frequently to the server, the more the thing goes more smoothly. Okay, that's when a mistake that people make when people don't have the habit enough to use this tool, and they would wait and wait and wait and wait before they actually commit the code. Okay, so you don't want to wait as much as possible. You want to commit code as frequently as possible. There's another variable that comes into effect here is that, of course, you don't want to commit code that is problematic. Okay, you want to commit code, for example, that compiles. You don't commit code that you did not compile. If you have tests in place, you don't want to commit code that makes the test fail. Okay, so that's something we'll cover after that later on in the lecture. Okay, so you have a server that contains the version that everybody is somehow getting a snapshot of as frequently as possible. And then you have your different clients here that are actually using this and then getting a snapshot, working a little bit, and then committing as frequently as possible so that other people can actually get the latest version and then continue working. So it's really a kind of a client-server architecture. Though, as we'll see later, it's a little bit more complicated for Git, for example. Okay. Okay, so this I already all mentioned. So here I'm gonna talk about the different concepts or operations, or basically talking about terminology here. As I hinted at before, here there is different terminology for different technology or specific solutions. Okay, so for example, Git would have their own terminology for what is a commit and what is a push and a pull and so on. Depending on what technology you are using, it may use different terms. So here I'm not going to go into a specific technologies terms. So don't assume here I'm describing Git, for example. Okay, I'm using some of the terms used in Git, but not exactly. Those of you who are, because there are out there, I know, probably in the class, some people that are like Git wizards. You might see that in my description of things here. You might see that it's not exactly like what Git, the terminology or definitions that Git is using. Okay, so here I'm just describing concepts. So there's the term repository. So the repository is actually this repository that you have here. Okay. In Git, you also have a repository locally, which is a different issue that is specific to Git. A repository is essentially this essentially data structure. You might say it's a database of some sort. The repository is not just a set of files. It's not a directory on a disk drive. It's some kind of data structure that actually contains the information that is stored in a file, and that actually stores all the changes that were applied to all the files in some kind of sequence. Okay, so it's not, the repository is not the files. Yes, it contains information to recreate all the versions of the files, but it's, in most cases, does not contain files. It contains a series of sequence of changes that were applied to files. So that's what is a repository. Then you might have terms like a working copy or a workspace. So when you open your Eclipse, then you have your Eclipse workspace. So that's basically essentially files, for example, Java files that are stored in a Java folder inside of your Java workspace. Okay. And then you have the working copy of the repository. So these, for example, in Git, these are two different things. So yes, you have the files that Eclipse is using, but your local version of the repository, when you get your version from Git, on your PC, you would have a local repository, which is not the files. Again, it's the same notion as here. It's basically some kind of data structure that contains the changes that you apply to the files that are on the repository. And then when you use the files, the real files, these are the files that are in your Eclipse workspace. Okay, so these two things should not be confused with one another. It's easy if you don't know how it works to confuse these two things together, and that leads you to not really understand what's happening. Okay, so if you don't know about how to use repositories, it can be confusing. So you have to take a breath and then try to see how it works. Okay. It is more complicated, of course, than use only files. It's not just a magical solution and everything runs very smoothly. If you don't know what you're doing using a repository, you may make mistakes in the sequence of operations that you apply, which can lead to confusion, and you may have to undo things and so on. So you have to be somehow careful when you want to apply operations. And okay, other concepts, notion of a commit. So you are working on your files on your Eclipse workspace. Then as you make changes to your files, this does not make changes to the local repository. If you want to apply the changes that you've worked on your Eclipse workspace, for example, then you have to do what is called a commit, so that the changes that you have applied will now be recorded inside of the local version of your repository. So that's called, operation is called a commit. Commit will record a change that you have applied, or a series of changes that you have applied since the last time you have made a commit. And you can actually push, as you can not push, you can actually do as many commits as you want. Then when you make a commit, especially here I'm talking about Git, when you make a commit operation, then that only records it here in your local repository. If you want to make these commits part of the global version that's on the server, then you have to push, to tell the local repository to push on this remote version of the repository. So commit and push is not the same in Git. Commit is committing to your, generally speaking, commit is committing to your local repository. If you want to put your latest version or changes onto the remote repository, you have to do a push operation. There's also the notion of checkout, because you can have different branches, as I hinted out before. If you want to switch to another branch, so there might be different branches here in the repository. So if you are working here on a certain branch, and then suddenly you want to switch to another branch, then you have to do a checkout. Allows you to actually switch branch. Okay. And then that would actually make the files appear in your Eclipse workspace to be changed with the version of the files that are existing on this branch. Then you also have pull. So on the other side, if you are working here and then somehow you are made aware that somebody has has pushed on the, for example, you're working here, you're doing your own changes, and then as this person is working here, they're making some commits here, and then they will push. Then this will actually update this, the remote repository. And then very often, as for example, you'd be using, if you're using, for example, source tree, which is a tool that I'm using, then source tree will tell you, as somebody is pushing here, and source tree will be telling you, oh, there were some versions that were pushed on the server. So then it will prompt you to actually do a pull, so that you will actually get all these changes that were applied here, or these commits that were applied and pushed here. And then it will actually get these changes and then update your files according to the changes that were pulled, that were pushed by this person here. So after somebody has pushed something, if you want to get the version, the changes, then you have to pull these changes to apply, to have yourself in your local version, the latest version. Another thing, I'm not going to go into all of them here, but one of the things you can do is what is called cherry pick. So as you see, for example, on the server, that there is, for example, you are at a certain state here, and then you see that there are things that have been pushed and that you want to pull, then you might see, for example, there's a list of different things that have different changes that have been applied that you may want to pull. Cherry picking actually means that you may want to, essentially that, cherry pick. You want to pick this one, and then cherry pick them, and then actually make only these changes here in your local version, and you leave the others there. Okay. There are lots of things that you can do like this. Here, I'm just giving you an example. Okay. So yes, there is commit, push, pull, checkout. These are the basic ones, but there are many others. The objective here is not to show you all the intricacies of using Git, for example. You may have in your team what I may call a Git wizard, which are incredible people that can do a lot of things. That's not my case. I'm not a Git wizard, but I can use Git when I work in teams or when I work by myself. But I'm not a very advanced Git user. And I know that these people are actually very valuable people to have in your team. I have some people in my research team that are very good at that, and I'm happy to have them when things go wrong, because things often can go wrong if you make some mismanipulations in your repository. So yes, there is much more than what I'm teaching you here. What I'm teaching you here is just the basics, and I'm not expecting that you would do more complicated things than what I'm showing you here. Now, what about branches? So the idea is that, so this is, for example, a tree or a network that describes the evolution of your software. So it goes in this direction here. It goes from top to bottom with increasing numbers here. So that's the first version that you had. Then what's in green here is what's called the trunk. So it's basically the main branch. Okay. So it's possible that in your team, you may not want to use branches. I would say if in the team, you don't have somebody who is very good at this, at using a repository, you better not use branches. If you have some people that are at ease with the tool already, they will know what's the value of using branches, and they will know, they may be able to guide you as to how to use them. Okay. And often guide you as to how to, what mistakes not to do when you use branches. So branches is a very good feature to have, but if you don't know what you're doing, it's likely to create more problems. Okay. For example, if you go on a branch and then you, with the intent of actually branching out, doing some development and then branching in, if you make some crucial changes to crucial files along going in your branch, then when you're going to branch back in or merge, it's likely that you're going to have merge conflicts, okay, which are likely to be difficult to apply. So yes, branches are good, but it's also, you need to make sure that you know what you're doing if you're using them. So yes, so that green here is the main trunk. Then you can go at any point in time, you can create a new branch. And what it does is basically when you create a new branch, the branch is created by, or is evolving in a different direction that is not actually influencing the changes that are happening here. So if you apply changes here, then it applies changes from the files that are as the version here, but then they would start being their own evolution branch. Okay. So if you make changes here, it does not affect the version that is here. And that's what you want to do when you do a branch. You want to make some changes that don't affect the other part of the other branches, including the main trunk. Sometimes you may want to do a branch in the predefined idea or intention to actually merge back after. So you branch out, and then when you branch back, it's called a merge operation. Of course, when you merge here, then the more the branch has went, the more the branch went a long way with more changes away from the main trunk, the more it is likely that when you branch back again, there's going to be some conflicts. Okay. Conflicts are not so fun to deal with, especially if there's many of them as you do one merge operation. Though also there might be some cases where you make a branch and you have no intention to actually merge back. Okay. For example, I don't know if that's a good example, but let's say you might have the main version of your software here, which is, I don't know, the English version. And then here you have the French version. So you, and in this case, they would be disjoint. Or you have the Windows version, and then at some point you have the Linux version. Okay. And the idea is that you will not totally branch them together. Of course, that may happen that there's intersections between each of them, in which case you may have to actually do some partial merges along the way. Anyway, this is going much more complicated than I intended. I'm not expecting that this is going to happen in your project. So, okay, and then at any point in time, in any branch, you may actually tag a certain version and give it a name so that later on you can actually have a name tag to actually refer to a specific version. So that forever after, you can actually ask the repository, give me version T1, for example. And right away it would know, because you gave a name to this version, you would know what specific version that is. So normally you do that, for example, when you have a build that is finished, that has been delivered, you may tag it. So that's what we're going to ask you to do in the project. So that's it for branches. So there's many other concepts that you may have, especially in Git. There's a lot of different concepts, a lot of different commands. And that's one of the things. When you use, for example, GitHub, you can be in the illusion that this is all a graphical user interface. Fact of the matter is that Git is actually much of a command line kind of software. When you are doing some clicking on the user interface, the clicking is actually translated into command line, basically commands on a command line. Okay. So Git is essentially a command line tool that you can actually have some kind of graphical user interface whose job is just to create the commands. Okay. And there is a very substantial amount of different commands, and Git is notoriously a very complex kind of system. You should not expect when you start that you know everything about Git. It takes it's quite a difficult tool to learn the entirety of it. It's a very intricate kind of system. You can use it in a simple way, and that's what we're trying to do in this course, but it is a very intricate kind of system, complex kind of system. Okay, so here I'm just giving you some hints about how can this be organized? how does the repository actually work? How does this store this information, these changes to your files? So as I said before, maybe you think, well, these are files that have been stored in the server. No, this is not files. Well, there are some that are storing files, but most of them are just storing changes. Okay. And that's the first one here, the deltas. So essentially you have, for example, let's say you have, very simple example, you have 3 files in your piece of software, file A, B, and C. So this is your version 1. That's the first one that you upload. So that's the only one where you would actually have files, the first commit. Every time you commit a file for the first time, it is, of course, a file. But, But then after, for example, in version number 2, let's say you change the file A and then you commit your change, what is actually stored in the repository is what's called a delta. So basically it is, what is it that in file A that was actually changed? So it basically records what are the actual characters in your files that were changed in this particular file. And if you make changes to more than one file, then it would actually store different deltas for each of the files that you have changed. Okay. So you see that it does not store a new version of your file. It basically stores what was changed in one of your files. So you see that it requires quite an elaborated machinery in place to recreate, for example, let's say create the version 5, then it would get the initial files, and then it would apply these 2 changes to file A, these 2 changes to file B, and then these 3 changes to file C. Okay. Yeah, you have some of them, quite a few, only a few that would actually store files. So in this case, if you store the initial files ABC, that would be what is actually stored. Then if you make a change to file A, then it would store a new file. And then if you don't make a change to file B in your version 2, then it will actually store nothing. And if you retrieve version number 2, it would retrieve the latest version, which is the version number 1. In this case, it would store files, but this model is not very often used. Now that was for how it actually stores the changes or keeps track of the changes applied to your files. Now, how does it work in terms of example here, I was explaining to you that this was essentially a client server architecture. So what is the architecture of the relationship between the user and maybe a local repository, the remote repository? So what are the different solutions here? So the first versions of revision control were actually totally local. So a single person is making changes to their files and they want to maintain a record of what are the changes applied on their local computer. So of course you could have a solution that does exactly what I said using deltas, for example, but you would then have only changes that are applied on a single computer by a single user. Okay, so that's how it actually started. I would say decades ago. So that's basically a local version of this solution. Of course, what we want eventually is to be able to work as a team. As soon as you add more than one user, then you need to have some kind of telecommunication that is happening between computers. And the first way that people figured out is to actually have a server. So that as I create the version, I'm actually pushing this version on a server, assuming that other people will connect to the server and get this version. And that eventually we are going to all connect to the server and make changes and push the versions, which the server will keep track of the changes that are applied by all the different people. That's the model that I was describing you before. Yeah. That's essentially you have here you have distributed versions. So each of the persons that are working have their own different version as they make some changes locally, and then they can actually, and that makes different versions that are concurrent. Then you can actually push these versions on the server to merge these concurrent versions together. Of course, this enables teamwork, and that is much better for a sizable project management. Now, what are the disadvantages of this? So basically that's assuming that what this creating is that you have a single place where all your files are stored. If this server crashes and loses the files, then everybody lost everything. That's what it's called, single point of failure. There's also access potential access rights problems. If you would have many different servers, then that would actually somehow solve this problem. Not necessarily. Well, that's how it went eventually in order to become what Git is, which is essentially a distributed repository. In this case, what you have, that's essentially the Git model. Yes, you have the server that actually contains the version that is the concurrent version that is managed across different users. So you can have different users that are connected to this server, exactly as I was describing before. Except that with Git, what you can do after, for example, you get this version from this server, you can create your own local version and become yourself a server. So it's possible that another user will be able to, for example, push to or pull to your own server. Okay. So this way it becomes much more flexible, and then people can have their own local copy that they can share with as a subgroup to have people work on a certain somehow branch of the software that does not influence the main one that is stored on the main server. Okay. So essentially here what's happening is that yes, there's a server, but anybody can actually be a server. Okay. Of course, that's creating a lot more possibility, but also potentially a lot more confusing situations. In the course, of course, we're not going to use this feature that you can actually act as a server. We're going to basically use it as a normal client-server architecture. Like you don't have to use this feature here that everybody can be a server. This is very often used, this model here, when people work on free software movement, where people can, for example, work on a GNU implementation, which is, a free software, and then they develop their own version or different capacities, and they make the free software evolve in time, and then they provide their own version, they advertise their own version, and then other people try it, and then eventually they come to a point where they say, that is a stable version and that's something that GNU themselves may want, then GNU can decide to take this version and then merge it with their own version. That allows much more flexibility, makes it even also more complex. So what are you going to do with this in the project? So those of you who already know how to use, for example, GitHub, I mean, you will be at ease here, but there's a lot of students in the class who don't know how to use this kind of solution. So that would be nice if you could have some people in your team that already know how to use this solution, that you would coach those that don't know. But don't be afraid either. We're not going to expect that you do very advanced use of a repository or specifically Git. Okay. So what is it that we're expecting? Every team member should have multiple commits during the production of each build. So when there's going to be a build that's going to be delivered, one of the things the marker is going to do is going to check the number of commits by each team member. There should not be, for example, 1 or 2 team members that have something like 2 commits. Okay, there should be a somehow high number of commits by everybody in the team. If you are novice to this solution, make sure that you actually, even if it's not a large large commit, that you figure out how to retrieve the version, make a simple change, and then commit. Okay. Main thing here is to get the habit of using the tool. Okay. Maybe you're not doing things which are sizable in the beginning. That's not a problem. What we want to see is a number of commits done by everybody in the team. Overall, for the team, there should be dozens of commits for each build. So don't go into the habit of many people have to say, okay, I'm going to develop this entire, let's say I'm given a certain requirement to implement. I'm going to develop the whole thing. And when I'm going to be finished, I'm going to give it to the team. No, that's not the way to do. So as you're developing this here, as it becomes stable at some point in time in the development, you push the commits onto the server so that other people can actually see it and use it. Okay. So that's the habit I want you to take. That will lead you eventually to have dozens of commits as a team. At the end of the project, there's always a few teams that actually have hundreds of commits. Okay. So that's the kind of thing that you should aim for. People that know how to use such a tool and work on a project like this, they will have hundreds of commits at the end. Okay. That doesn't mean that the more commits you have, the more you have success and the better you are. But people that have experience with such a tool will know that you have to do very frequent commits. It works better the more commits you do. Commits should be well distributed over the duration of the production of the build. So if I see, or if the marker sees that, let's say the deadline is here, and then all the commits are crammed in the day or two before the due date, that's not good. Okay. Yes, we understand also that this is a course, so probably you have some work to do in other courses, but don't. It's much better if you space out your you put some space between you do your commits separated in time. Okay. So if you don't know how to use so what we're going to advocate to use, what's going to be taught to you in the lab is GitHub. Okay, so there's already a video that's there to show you how to use GitHub. If you go in the lab instructor will be able to show you how to use GitHub. If you use something else, then you have to make sure that if you are to make a decision of using something else, you have to make sure that if you want help, that the lab instructor knows it. It's possible that you realize that you have people that are knowledgeable in your team that can coach the other people in your team in using something else. That's fine, but be careful with that, because that would require or put more pressure on the people that have this knowledge to actually invest some time in coaching the others. Okay. Another thing that I'm introducing this semester is the use of what is called a continuous integration tool. Now, yes, you're doing some commits, but the thing about commits is that the revision control system will not ensure that the commits are actually somehow correct, that the code is correct. Now, what does that mean, correct? So for you know, when you commit something, you're basically committing characters in a file. The repository does not know if it's correct code. Now, what is correct code? It can, for example, mean that the code will compile, that if you commit a certain change, that if you compile the whole project after this change, that the project will still compile without errors. Okay, that would be one way to check that the code is correct. Now, we all know that code may compile, but it may contain bugs. Okay. Now, the other thing further that we'll be asking further down the line is that as you make a commit, that yes, it must compile, and also it must respect or the tests that you will, the JUnit test that you will have will actually pass as you make the commit. Okay, so we'll be asking you to implement the machinery in place using a continuous integration tool that is implementing these actions. And that's what we're going to do. We're going to advocate to use GitHub Actions. GitHub Actions is a specific solution to actually run these commands as you actually commit your code. So that actually enforces somehow that you commit code that is somehow correct. So that's it for that. So see you on the next video. Thank you.